All right, guys, we're back with section 7 of chapter 1, dealing with functions. So previously you solved equations with elements from a replacement set. Now we're going to determine whether a relation is a function and also find function values. So a couple pieces of vocabulary here. We're going to talk about what a function is, a discrete and continuous function, vertical line test, function notation, and something called a nonlinear function. So let's first talk about how to identify functions. A function is a relationship between an input and an output. In a function, there is exactly one output for each input. So you put a number into the function and you get one number out. All right, so a function is a relation in which each element of the domain is paired with exactly one element of the range. Okay, so it's worded precisely because a couple things can happen. Each number in the domain only has one number that it goes to. Okay, like -3 goes to 5, but it doesn't go to any other numbers. 0 goes to 3, but it doesn't go to any other numbers. Now, if you look on the graph here, graphically what's happening is, remember, the domain is the set of x values and y is the set of range values. So any numbers on the x-axis would be elements of the domain, and numbers that lie on the y-axis would be elements of the range. So this point right here, at the bottom of that little valley right there, is the point 0, 1. So 0 is paired with 1. Now, this mapping diagram is not the mapping diagram for this graph, so just beware of that. Okay. Now, I will also show you that right here, another function value is also paired with 1. It looks like it's about -2.8. -2.8 is also paired with 1. So elements of the domain can be paired one number at a time, but they can be paired with the same number. But you will never see like -3 paired with 5 and 7. If that happens, then it's not a function. And we'll get a little bit more into that a little bit later. So determine whether each relation is a function and explain. So here, is this a function? Well, is each element in the domain paired with exactly one element of the range? That is true. Now, if you look at 0 and 3, they're both paired with 6, but that's okay because only one arrow is coming off the 0 and only one arrow is coming off of the 3. Okay? So just be aware of that. So that is a function. Now let's look at this table. Is each element of the domain paired with exactly one element of the range? No. Now you'll see that 4 is mapped with 1 and 5 from the domain. So 1 and 5 both go with 4. That's okay because the 1 only goes to the 4 and the 5 only goes to the 4. What makes the problem is that the 1 also goes to -4. You see how an element in the domain is paired with two different range values. That's why that is not a function. Okay? It only has to happen once and it breaks the rule. All right, so here's one for you to try. Go ahead and pause the video and hit play when you're ready. Okay, we're back. Is that a function or not? No. It's not a function because you can see the x value of 2 is paired with two different y values. Let me make a domain and range mapping diagram. The domain consists of 2 and 3, and the range consists of 1 and -2. The 2 is paired with 1 and -2, and the 3 is paired with 1 and -2 as well. Now, it wouldn't matter if all the numbers in the domain all were paired with 1 or are all paired with -2. That's not the problem. The problem is that an element in the domain, in fact, 2 of the elements, are paired with two different numbers at the same time. So 2 has 2 arrows coming off of it, and 3 has 2 arrows coming off of it. That's why that's not a function. Okay, a graph that consists of points that are not connected is called discrete. A function graphed with a line or smooth curve is called a continuous function. Okay, so that's why you have to be careful. A graph that consists of points that are disconnected or not connected is called a discrete function, and a function that's a line or smooth curve is called a continuous function. So ice sculpting. At an ice sculpting competition, each sculpture's height was measured to make sure that it was within the regulated height range of 0 to 6 feet. The measurements were as follows. Team 1 was 4 feet, Team 2 was 4.5 feet, Team 3 was 3.2 feet, Team 4 was 5.1 feet, and Team 5 was 4.8 feet. So let's make a table of values showing the relation between the ice sculpting team and the height of their sculpture. So Team 1 through 5 and their respective heights. Alrighty? So second, we want to determine the domain and range. Well, the domain is just the set of x values, and y is the set of range values. Now, if you think of domain and range as your x and y, remember x is always the independent variable, and y is the dependent variable. So the height depends on which team you're talking about. So team is the independent variable, and height is the dependent variable. And that's how we kind of determined which one was an element of the domain and range. Now we want to write them as ordered pairs. All you do is take the numbers from the table, and like 1, 4, 1 is paired with 4, so 1, 4. 2 is paired with 4.5, so 2, 4.5, and so forth and so on. Then we want to graph the data. So what you do is you plot those points. Now this is where you have to determine whether or not you connect the points. Now here's the thing, when you connect the points, the line that you draw through the points is implying that there are other points on the line that are in between the points that are you connecting. Should we connect these points? Are there more points than what's in the table? No. So there are not more heights between the given heights because there's only 5 teams. So you're just going to graph them as a collection of points and not connect them. Okay? So is this function discrete or continuous? The function is discrete because the points are not connected. How do we know they're not connected? They're not connected because there cannot be heights in between the other team numbers. There's not like team 1.1 or team 1.2. You know, the other numbers that are available on the graph don't make sense in the context of this problem. All right, here's one for you to try. Go ahead and pause the video and hit play when you're ready. All right, we're back. So a bird feeder will hold up to 3 quarts of seed. The feeder weighs 2.3 pounds when empty and 13.4 pounds when full. Make a table that shows the bird feeder with 0, 1, 2, 3 quarts of seed in it, weighing 2.3, 6, 9.7, 13.4. So here's a table. Oops. Let's go. This is quarts, and this is pounds. Quarts and pounds. So number of quarts, 0, 1, 2, 3. And the corresponding pounds would be 2.3. Now, how can it weigh 2.3 pounds if there's no seed in it? Because the bird feeder itself has some weight to it. 6, 9.7, and 13.4. Okay, so determine the domain and the range. The domain is the set of 0, 1, 2, 3, and the range is the set of 2.3, 6, 9.7, 13.4. Alrighty, so now if we graph the set, 0 is paired with 1, which would be right about here. 1 is paired with, or excuse me, no. 0 is not paired with 1. 0 is paired with 2.3, which would be right about here. 1 is paired with 6. 2 is paired with 9.7, which would be almost 10. And 3 is paired with 13.4, which is like right there. Now, would it make sense to have amounts of seed between 0 and 1? Well, in this case, yes, you could pour a half of a quart, you could pour a quarter of a quart, you could actually have all the weights in between 0 and 1. In fact, if you think about actually pouring bird seed into a bird feeder, it's going to actually pass through all the weights as you fill that up. So it would make sense to connect those points to make a continuous function in this case. So yes, the function is continuous because you can have weights that correspond with amounts in between 0 and 1, 1 and 2, 2 and 3, and so forth and so on. Okay, all right. So you can use the vertical line test to see if a graph represents a function. If a vertical line intersects the graph more than once, then the graph is not a function. Otherwise, the relation is a function. So this graph is a function because if you pass a vertical line, you just put your pencil on the screen and go from left to right, and it'll only hit one point at a time. This one, however, if I passed a vertical line through it, you could see it would hit it 2 times. It only has to happen at least 1 time, and then it would be considered not a function. So is this one a function? Yes, actually, because no matter where you put the line vertically, even if you put it right here, it would still only hit 1 point at a time. Why? Well, because right here, this open circle means the line starts there but doesn't include that point. This closed circle means this line ends there and does include that point. So if you slapped your vertical line on that piece right there, it would actually only hit 1 point. So recall that an equation is a representation of a relation. Equations can also represent functions. Every solution of the equation is represented by a point on the graph. So like you put an x value in and you solve it to get the y value. That x and y value represent a point on the graph. The graph of an equation is the set of all solutions, which often form a curve or a line. So determine whether negative 3x plus y equals 8 is a function. First, you can make a table of values. And I always suggest do some negatives, do 0, and do a positive for your x value, and then figure out the corresponding y value. So what you could do in this case is put negative 1 in for 3, and then solve the equation for y. So if you put negative 1 in for 3, you would get negative 3 times negative 1 is 3, plus y is going to be 8, so y would have to be 5. And then if you continued on with these function values. So if you put 0 in for x, I don't know why that has a 4.5 in there, but that should be an 8. Let's change that to an 8. Okay? So connect the points with a smooth graph to represent all the solutions. Now, how do we know this is a continuous function? Well, we just picked different x values, but you could pick all the values in between there if you want. So you would plot the point negative 1, 5, 0, 8, 1, 11, and 2, 14, which would be way up here, and then connect them with a smooth curve. The graph is a line, and to use the vertical line test, place a pencil to the left of the graph to represent a vertical line, and then move it from left to right across your graph, and you'll see that only 1 point touches the vertical line or touches your pencil or pen at a time. Therefore, this function, or this relation, this graph is a function. So here's a couple for you to try. Go ahead and pause the video and hit play when you're ready. Okay, we're back. So this first one, 3a, if I do a table of x and y values, if I pick some negatives, notice that no matter what I put in for x, if I put negative 2 in for x, that's not gonna work. So that can't be. In fact, you know, if you divide this by 4, you would get x equals 2. You know, divide both sides by 4 to solve for x, which implies that no matter what y value you use, the x value is always going to be 2 because there's no y in the equation. So here's how this would look. If I go over to, let's say this is 1 and this is 2, it's just going to be a vertical line in this case. X equals 2 is a vertical line. So anytime you just have x and it equals a number, it's going to be a vertical line at that number. If you had just y, it would just be a horizontal line at whatever that y number is. Now, this is obviously going to fail the vertical line test because a vertical line intersects a vertical line at all the points. So nothing going on there. That is not a function. So 4x equals y plus 8. So if I make a table of values, Let's get a couple table values on the table. If I put -2 in for x, you would have -8 equals y plus 8. So y would be -16. If I put in -1, you'd have -4 equals y plus 8. So y would equal -12. If I put 0 in for x, it would have 0 equals y plus 8. So that would be -8. If I put in, let's say, 1, you would have 4 equals y plus 8, so this would be -4. And if I put in 0 for x, you would have 0 equals, or excuse me, if I put in 2 for x, you would have 8 equals y plus 8, so the y value would be 0. So we can graph a couple of these points. So if I put in 2, that would give me 0. So let's just say this is 2, that gives me 0. If I put in 1, that gives me -4. And if I put in -1, that gives me -8, which would be down here. Connect them with a smooth graph. Okay. And then yes, that is a function because that graph would pass the vertical line test. Okie dokie. All right, a function can be represented in many different ways. You can have a table, a mapping diagram, an equation, or a graph. And it's going to be important to be able to go back and forth between these different representations. So that's it for this section, or for this first part of this section. In the second video, we're going to talk about how to actually find function values. So stay tuned for that one.